Good evening, and thank you for coming to Failure in Data Science, or advice for when things go wrong. This is the second in this series, if you will. We're trying something new and trying to have some talks that kind of go together. The previous talk was becoming a data scientist. If you haven't seen it, don't worry. I'll call out things that were in the previous video, but please go watch it. And this is about my experiences and approach. This is going to be shorter than the other one because we want to leave some time at the end for people to discuss things and share their experiences and their failures in data science. But please don't construe this as the opinion of my employers, past, present, and future. I'm an independent consultant, and these are my opinions. And a quick summary, there was a failure during that first presentation, and I'm going to use that as a practical example of how to handle failure in data science and failure in general. Starting off with some definitions. Step one is define your terms. We're going to talk about what is failure and how we can use that definition in a business or data science context. During a failure, while you're experiencing these hardships, I want to give some advice on how you handle it. After the failure, after you've resolved whatever difficulties, how can you learn and improve? And then some conclusions at the end. So starting, what this talk isn't. I'm not going to give you a bunch of inspiring platitudes about how you learn more from failure than success, or success is moving from failure to another without loss of enthusiasm, or, I get knocked down, but I get up again because you're never going to keep me down. While all those things are true and can be inspiring, that's not what I want to cover tonight. And I also don't want to disregard the emotional impact. You may freak out. You may feel like you're just in free fall and don't know what it is. You may feel a bit morose, but hopefully you avoid the worst of it. So I want to acknowledge that the emotional side of failure, while you're failing, you can get a very emotional reaction. I don't want to disregard that, but it's not what I want to cover this evening. And then a number of tools to try to prevent or otherwise manage failures, such as testing, process control, validation, governance, etc. I could do an entire talk on any one of those topics, so I don't want to get into it tonight. And as an introduction, there were some studies by Gartner about data science and companies taking their first steps into analytics. And in this review from 2015, they say that they estimate 60% of big data projects will fail to go beyond piloting and experimentation and will be abandoned. That is, over half of the projects aren't going to be implemented in production and could therefore be viewed as failures. And you may think that after a few years of getting better, maybe that rate would come down and maybe the majority would start going into production. But in a later report in 2018, there is a prediction that 85% of projects will deliver erroneous outcomes due to bias in data, algorithms, or the team responsible for managing them. Now, the way it's written, I don't know if that's bias in data, bias in algorithms, or bias in teams, or bias in data, algorithms, and teams. And further, they go on to say that over half, or 53%, of organizations in their survey rated their own ability to mine and exploit data as limited, which was the lowest value. So you have this weird thing where over half of companies say they rate themselves quite low. A larger majority, 85%, are going to have some problems when they implement data science, and yet everyone seems to be going forward with it anyway. So if we look at failure, there's the dictionary definition, one of which is a lack of success. And in the Wikipedia definition, it says that it may be viewed as the opposite of success, and I want to stress that, in my opinion, it's not that binary, that you can have things that are neither successes nor failures. So that's my interpretation of the may in that Wikipedia definition. The other thing from that Wikipedia definition is that the criteria for failure depends on context and may be relative to a particular observer or belief system. So as a data scientist and as a business stakeholder, you may have different definitions as to whether or not something succeeds or fails. So if we look at it from a data science point of view, you may look at dirty data and say, oh, this is a failure. If it doesn't use the latest tools or best practice, if you're implementing data science in Excel, you may consider that a failure. If your model performance is worse than something, where you get that something is a little interesting. Is it the model currently in production? Is it your expectations? Is it what your neighbor does? But how you set that something, wherever you set it, if you do worse than that, you may consider it failure. And then finally, relative to the Gartner survey, if it's not implemented in production, you may consider that a failure. From the business stakeholder, though, If you want to know what they consider success or failure, the only real advice I have for you is to ask. And these are some questions that I use when I engage with stakeholders. That what does success look like? Again, I don't think success is necessarily the opposite of failure. There is some middle ground, but if you succeed, you don't fail. What do you expect from this project? It may be that you're looking to do some modeling and you would consider Excel a failure, but actually, they just want a dashboard. It's possible that you're looking at all the technical metrics, but you end up with this very complex model that the team you hand over to can't handle it, and they consider it a failure. So be careful from this. Remember that success and failure may depend on your point of view. And if you build the model, what will you do with it? Oftentimes, if things aren't scoped properly, if they don't understand data science, you can end up in that stage where you're not going to go into production. You don't know what to do with the model, even if you do have the data and a low mean squared error or whatever. And so what I want to stress here is make sure you understand success and failure from the business standpoint. Make sure you understand what your project is meant to deliver and how it will be assessed as to whether or not it succeeds or fails. Not just in a technical standpoint, that your model performance should be better than some number, but what does the business expect to get as a result from the data science? So what are perceived failures? In my education as a mechanical engineer, when you're looking at design, there's two main ways that a design can fail. The first is it doesn't work as advertised. You buy something for a purpose, and whatever you buy doesn't fulfill that purpose. So if my microphone doesn't record, if my clicker to advance the slides doesn't work, whatever you are buying something for, if it doesn't satisfy that purpose, it's a failure. So a related question is, what data outcome has been sold? And along those lines, there's a media out there for called The Credibility Crisis in Data Science. There's a blog, a podcast. It's up on YouTube. Here's a image of it with Skipper Siebold. It's data framed, the Data Camp podcast. It's pretty good, and they talk about a number of ways in which data science gets sold, which may or may not be realistic from a technical point of view. So I recommend that if you'd like to get some more information about whether or not the business outcome has been sold appropriately and whether or not you could have some problems even before you start based on expectations. And the other way things could fail is if it's low value. One way is that it's expensive. And you'll see discussions about should you be hiring data scientists or should you use software. There's some discussion about whether AutoML or Data Robot will suffice for data scientists and whether or not it's cheaper. The other comparison is comparing data science to business intelligence. So rather than what I consider data science or mathematical modeling, people might just want dashboards and Tableau. And whether or not business intelligence solutions are cheaper than data science solutions or cheaper than data scientists, you need to look at that value proposition. Another way in which things are low value is if it doesn't last long. And so if I build a mathematical model, how often would it need to be retrained? How would I hand that over to the business? And as I get new data, will I need to rebuild the model or will it automatically update itself? And if so, what are the implications of that? One problem along those lines is you end up playing a modified game of telephone. If you played telephone in primary school, because everyone has their own definition of success and failure, and you can have different communication paths, you can run into this type of organization where a data scientist has to talk to a data translator who then passes information on to a manager. And if you were playing telephone, the manager would go back to the data scientist and you would laugh about how the story's changed. And sometimes this happens, but not always. Sometimes you build some slides, they go up the chain, and then before the presentation, whoever's presenting will come back to you and say, hey, is this right? And often it is, but sometimes it's like, well, you tried to simplify this and actually it's not right anymore. But that link doesn't always exist. Sometimes you make slides and they go up the chain and you never see them again. But even when you do, oftentimes the manager then presents to the stakeholders. And even if the message is consistent, all the stakeholders' understanding and expectations about what's being delivered may also change. They might not be consistent. They might not be what you started with. And even if you ask the individual stakeholders what they think success and failure would be, based on the same presentation, you may still get different results. And you run into these cases where your data science pitch is there, it's upstanding and professional, kind of a Superman. You set the expectations for this data science project, and then you look at the data coming up and maybe or maybe not supporting what was promised in the pitch. And this is kind of the gist of the credibility crisis, the podcast, blog, and YouTube video that I showed earlier. And this is what I'm going to call systemic or slow failures. You can see the problem very quickly that the data don't support the business direction. I've looked at data sets where there were 5 variables, an ID, a treatment, an outcome, another ID. And so suddenly I had a 1 variable model, and whether or not that was predictive didn't matter. And when you run into these situations, sometimes it's easy that you can just sit back and watch the train wreck. But if it's your responsibility to somehow fix it, you might not be as happy as the gentleman here. So when you're doing with these systemic failures, they are quite common in data science. It's often a big competency gap between technical and managerial staff. IT expertise, programming expertise, mathematical expertise, software deployment, and CI/CD pipelines. Also remember that this landscape is evolving very quickly. With the move to working from home, a lot of internet solutions, a lot of collaborative solutions, using version control, using these CI/CD pipelines, with it all moving so quickly, even if you're an expert today, in a year, you might be obsolete. And you can see this in examples. So you get existing or legacy software solutions in Excel. And it's a collection of Excel macros, and no one really knows exactly what it does. But if you're trying to do data science, going from Excel macros to R, Python, etc., that can be a challenge. You can have legacy hardware. If you go to the airport and check in, these days you can go self-service with all the touchscreens. But when you go to the gate, look and see what the people checking in do. Oftentimes they don't have a mouse. And if you're late boarding the plane, you can hear the printer. And it's the old-timey printers where you rip off the sides because it force feeds. So if you have these legacy hardware issues, you might not be able to do data science because the infrastructure doesn't support it. And you can have unintended consequences. If you've seen The Social Dilemma, they talk about using the like button was to try to promote engagement and feedback to the algorithm. But then there became some psychological issues about people not getting enough likes and whether or not they would continue, or whether or not they would, had they known the impact, if they would have invented it in the same way that they did. And so if you're going to look at some of these things, my first recommendation is if you're going to criticize something, be prepared to propose and defend an alternative. It's easy enough to say, look, you shouldn't be using Excel, but then you need to say what you should be using. And then to the next point, you're going to probably be doing incremental changes with testing and reconciliation along the way to bring your stakeholders along and to give them confidence that what you're doing works. In my previous talk, the Becoming a Data Science talk, the first in this series, I had said that much data science work is actually change management. And this is what I meant, that if you're going to go from some very manual, very expert-driven solution into something automated, you're going to need to be careful that you build confidence and capability with what you're changing. And the other type of failures are these unexpected, or fast, if you will, failures. To contrast to slow, which is when everything is fine until it isn't. And this isn't mutually exclusive. You can have both at once. So as an example, you may think that the process to get a job as a data scientist is broken, with making your CV and replying blindly to job ads, and that might be a slow failure, but you can still forget your cover letter or have typos on your CVs, right? You can still have these unexpected failures even in slow failure environments. So as an example, forgetting attachment in an email, I'm sure we've all done that. You find some bugs in your code that all the other processes didn't find, or even outside of the data science, if you're taking a trip and your car doesn't start, now what? And so from the previous talk, what I want to cover is on the day of the talk, registration stopped working. So people were unable to register, they were unable to get the link, and as a result, people weren't able to view the last talk in real time. Now the site we were using, we had used previously, and it had worked previously, and in fact, my wife registered the night before. So the night before, everything was fine. The day the majority of people were trying to register, it didn't work. And this is what I mean by unexpected failure. Systematically, it had been tested, it had been working, and everyone who registered early was able to join, but on the day of, when everyone was trying to get in, it stopped. And I'm going to use this as a case study so that I can go through when we realized that this unexpected failure was happening, how did we handle it? As an aside, this meetup presentation, the day of, there was an outage on Meetup, which kind of, oh no, here we go again. But I'll just have to, comment and wait, Meetup's down. I can't comment. I could try to send everyone a message, but that's on Meetup. I can't do this, and it looked like failure again. So how do you handle it during a failure? The first step is to communicate. I know you might want to hide, but just try to be factual and impartial. Not dismissing the emotional aspects, but try to be as communicative about what's happening as possible. And I want to talk about the language here. There's a difference between saying there were bugs in the code and I made mistakes in the code. If you want to take responsibility for your actions and say, I did this, fine. If you want to blame yourself, if you're feeling down on yourself, I advise very strongly that you stay away from that. A step further, I don't think you should say they made mistakes in the code. Not during the failure. Try to deal with what's happening, not blame. In my opinion, if you blame someone, that actually looks worse on the blamer than the blamee. So, first of all, don't say things in a blaming situation, and that includes, and especially, blaming yourself. And so when we had this problem with the registration not working, I had put up a link to say, hey, everyone please make sure you register, and then there were comments in reply to mine saying, hey, I can't, what's going on? And we did some debugging, and I'm not putting the people who replied to my comments out of their privacy, but this is where we started to see what was happening and do some debugging and some communication of, okay, I acknowledge that there's a problem. The next thing is to try to stay calm. Again, not disregarding that you might not feel so calm. And so here, this was a comment that I said, look, we're going to get started, realizing that people can't register and can't get in, but it'll go up on YouTube. And what I'm doing there is I'm trying to focus on the impact. Yes, I understand emotionally people are very upset that they can't get into this talk, but at the end of the day, the impact is they're unable to see the talk, and I can mitigate that by putting it up on YouTube. And in general, if you talk about the impacts rather than the failure, it can be an easier way to rationalize and get you through. To a certain extent, if there's no impact, you could see that as no failure. Several of my friends emailed me to apologize saying, hey, something came up in my life. I wasn't able to get your talk. I'm sorry. And I was able to say, don't worry about it. Actually, you couldn't have gotten in even if you wanted to. So we were both in this sense that we had our own failures to deal with, but in a way they cancel out. And this is what I mean by I don't see success and failure as being exactly opposite, that you can be neither. And when you're looking at the impacts, there are some questions I think you should ask yourself. The first and most important is, because of this, whose health is in danger? And working in data science and banks, most people look at me very confused when I ask them this question. But having worked in areas that could be life and death, this is the place to start. And in particular, make sure you answer this relative to yourself. If you've had a string of bad luck and your mental health is deteriorating, that should be included in your answer to this question. Certainly, if you're considering self-harm, make sure you acknowledge that, and that's more important than the other impacts I'll be discussing. The next question is, which laws have been broken? In data science, with privacy laws, with GDPR, with some of these other things, it's possible that if you've had a data leakage or you're making some discriminatory judgments, It's possible laws have been broken in data science, but otherwise, if the answer to these two is neither, the impact is fairly minor. And there are other concerns, of course, reputational damage. When this talk didn't go forward, I was fine myself because I can put it up on YouTube. And actually, it's better for me if people go to YouTube. But I was concerned for the reputational damage of the people who had organized this for me. Blame and shame, again, I'm not blaming myself. I'm not blaming them. I'm not even blaming the video conferencing site we were using. Blame and shame can be very powerful, and for that reason, I encourage you to really consider whether or not it's worth pulling out such powerful weapons. And then the question of whether or not it's suboptimal. Now, in the case of people not registering for the meetup, they had to watch it the next day. And some people may have made special arrangements for care of their families, their children, and they would be unable to watch it at another time. But for most people, it's a reallocation. For the people that couldn't watch my talk in real time, it was better. And if you're running data science and you have like a recommender system, if it's recommending things poorly, that's different from, and then it crashes the system. So think about whether or not your impacts are suboptimal or wrong. And it really helps to focus on the impacts, not the failure. And to this extent, at the last meetup, given that it failed, I was looking at how many people were registered. And the last one, there were 78 people registered, and this one, there were 85. So individual people may have been turned off and not come back, but the numbers here are close to the same. Now, there's a follow-on to this that the meetup was listed in two different events, two different groups. And the other one had about 100 people registered, so about double. But now I start to ask myself questions about should I spam my meetups on every event? Because it's virtual and you can log in from everywhere, I could be on Sydney meetups. I could be on meetups around the world. There's a question for me about where do I want to advertise? How many different events do I want to be in? How do I manage the relationships with all the other coordinators if I'm in multiple groups? And why does the number of people who register matter? And I was reflecting on this, that when I was talking about unintended consequences and people getting concerned about how many people like their social media post, is it the same here with the number of people that register to attend? Is there a reason why more people attending is better than otherwise? There's no fee. I'm not getting paid per member. I'm not getting paid per view on YouTube. And what I'm really after is the engagement with people. And is a large group less susceptible for that? And should I actually be looking at smaller groups even than 85? My point here is when you're looking at failure like this, it gives you a chance to go back and reconsider your metrics. And if you don't know how you're going to evaluate the impact of a failure, maybe you don't understand your metrics very well. It's easy enough for me to say that I'm looking to get higher engagement with junior data scientists, but I'm not sure how to define that. And by trying to estimate the impact of this failure, that's really come to the forefront for me. So what do you do after a failure? How can you learn from this, and how can you seek to improve? The first thing is you can do a process review. What were the steps we took, and what could we do differently in the future? You can look at testing. If other people look at your model, in my case, if other people had used the software before, and monitoring, how often are you giving talks? How often are they failing? How is your model implementation going? Does it work next month the way it does this month? Is the business team, as a consultant that I would be handing over to, able to run this in production, or do they always need my help? Don't underestimate the human elements. When someone fails, and I was talking about that, I'm not going to discuss the emotional case. Just a quick note of, hey, I saw that didn't work out for you. You know, I It's a good model, it's just not performing very well, but I really learned a lot. A quick note after a failure to someone who was taking responsibility or potentially blaming themselves goes a long way. And to reiterate, after a failure, make sure you communicate. What did you learn? Part of me making this is to say, okay, that the previous presentation didn't go as well as I hoped. And these are some things about it and some things I want to do differently and better in the future. So as an example for the talk I'm giving now, we had changed video conference provider and we changed the process so that you don't need to register anymore. And then we had some contingency plans. I had sent the slides to the organizer so that in the event that I couldn't connect, he could present my slides. And of course, all this is up on YouTube again, so that if something happened on my end or something happened on your end, you can still see the talk. Now, the slow failures often become change management. Again, in my previous talk, I had said that data science often becomes change management. Well, if I'm going to really change the way I make content and present it, this is a change management problem, not a data science problem. So to conclude, failure will depend on your point of view, and so does success. In data science, there is a bit of a cliche about fail fast, and in some work environments, the idea is the faster you can fail, the less you throw good money after a problem, and the better off you are. So failure isn't always seen as bad, and in fact, sometimes if you can fail as quickly as possible so they know that their solution isn't feasible, that's celebrated. But I want you to consider these differences between systematic and unexpected failures, or slow and fast, if you will. Either way, communicate, and in my opinion, blame is worse for the source than the target. And to help get you through when you're failing, focus on the impacts, not the failure. And if you can mitigate the impacts, theoretically down to zero, in my opinion, if you make the impact zero, there's no failure. It still might not be a success, but that gives you that middle ground. And then you can look to future work to prevent future failures. And in my previous talk, I concluded you should study 3 things: boundaries, empathy, and communication. And once again, that's my recommendation here. Boundaries to understand that you will have failure, and it's not all your fault. Empathy to recognize that's the same for everyone else who fails, and communication to navigate through, minimize the impacts, and do better next time. So if you have any questions, you can find me online. I'm an independent consultant. You can find me at docsavagesolutions.com. Send me a connection request on LinkedIn. Watch this on YouTube. And then, not for this talk, but I have a GitHub account for the code for all my other talks. My other technical talks are mainly in R, and the code you can find there. For some acknowledgements, thanks to Citizen Data Scientist for virtually hosting this meeting, and an attendee who, again, I'm not mentioning her name for her privacy, but she sent me a connection request on LinkedIn saying, hey, looking forward to your talk. And I took my own advice and said, okay, well, here's a stakeholder. She's opening conversation. I need to ask her what success is. And so I asked her what she was looking forward to, and I think she was a little surprised that I replied to her. But she sent me what she was looking for in the talk, and I made some changes accordingly. And of course, thanks to Jiffy, because there are so many gifts and so little time. And to all of you for your attention, thank you.